Good day. We are gathered here today to talk about cyclic quadrilaterals. Well, that was a little bit ridiculous, wasn't it? But let's add some fun in the mix. Okay, so cyclic quadrilaterals. Maybe, again, I'm not sure where everyone's at in revision or not, but hopefully some of these are helpful for somebody. So if you're watching this, give me a little note, a thumbs up, a smiley face, something. Okay. This is going to be awkward when I get no responses or a sad face. Anyway, okay, so here we are. Cyclic quadrilateral. What makes something a cyclic quadrilateral? Well, what makes something a quadrilateral? Well, quadrilateral just means it's got four sides. So that's that. But what do you think makes that quadrilateral cyclic? Well, cyclic has to do with a circle. So what it means is that our four-sided figure is touching the circle. More correctly, the vertices are on the circumference of the circle, but loosely it touches the circle. And there it is. There's your cyclic quadrilateral. Okay, so it's a quadrilateral that's on a circle. Now, happy. Okay, so here we are. We've got a cyclic quadrilateral, and our first of two theorems says that the opposite angles of a cyclic quadrilateral are supplementary. Now, do you, just out of interest, have any sort of way of remembering which one's supplementary? There's that kind of supplementary, and which one's complementary? Which one means which? Okay, well, I don't know. The one that somebody, was it this year, last year? I don't know. At some stage, somebody said, well, the C you can kind of turn into a 90, and the 8 you can turn into 180. And now with the tomato sauce and mustard, just looks like that, doesn't it? You can see C complementary, 90 degrees, S 180. Other people say alphabetical. Somebody said C. Well, C is like in a corner, and a corner is 90 degrees. S like a straight line, so that's 180. I don't know, always interesting. Or you might have said, you know what, I just know which one's which. I don't need some mnemonic. But there's a little tidbit of interesting fact that I'm interested to see what you wrote as well. Okay, so we got our opposite angles of a cyclic quad, so they equal 180. So it means that if this angle B we've got, then we can find out which angle. That was going to be terrible. Here you get to see the bloopers. This is like everything's a blooper reel. I don't want that type of question. So B and D, we know that if we add these, left space, B plus D equals 180 degrees, and obviously you'd write your reason is opposite angles of cyclic quad. So B and D equal 180. Let's throw in another one. What are the other two angles that when you add them up, you get 180 degrees? Well, I'm hoping that we've got A, and so this angle and this angle, when you add them up, are 180. Little bonus question. Why do you think I didn't want to draw this with one line like that? So the same question I'm asking in various ways. Why do you think I didn't want to draw one line? Why do you think I've gone one line, two lines, 1 dot, 2 dots? Okay, I just want to be rigorous to show that generally if we've got something like that and that, it might mean that those two are the same. Not always, but maybe a dot and a dot makes it look like these two are the same. So I try and make sure that I've got it 1 dot, 2 dots. Doesn't mean this is twice as big. Just want to really show that they're not necessarily the same. So now the question that could be useful. In what special scenario will these opposite angles be equal to each other? Well, if they're equal to each other and they add up to 180, that must be 90 and 90. So if that's 90 and that's 90, well, is it going to be the case that these also have to be 90 and 90? I wonder. Could you draw something where that's 90, but that was like 10 and that was 80? Or not 10 and 80, 10 and 110. I don't know. But 90, 90, that's special. Okay. Our second and final one for cyclic quads is the exterior angle of the cyclic quad. Let's work through this with an example to say this angle over here. Let's say that it's 100 degrees, just as an example. What would angle M1 be? Well, it would be 80 degrees because opposite angles of cyclic quad are supplementary. Okay, well, if that's 80, what is the value of M2, this one on the outside? Well, yeah, it's 100 degrees because angles on a straight line. And it's always going to hold. Now, for those that saw this in class and do this, I don't know why the 180 just stick with me. They work so nicely, and I can do the numeracy easily. If I said that was 101 degrees, anyway. So 180. So in other words, this angle inside is always just going to be equal to the angle on the outside. So that's what this second theorem says, is that the exterior angle of a cyclic quad, so to create an exterior angle, we've taken our cyclic quad, and then at one point, doesn't matter which one, we've extended it out. So that's how you create it, just like the exterior angle of a triangle. See how it created it there? Is equal to the opposite interior angle. So it's not necessarily equal to that one or that one, but it is equal to that opposite, I'm on the way here. It's equal to that opposite interior angle. So M2 is equal to P. So maybe we could write that M2 is equal to P, reason exterior angle of cyclic quad. Okay, so that's that. So I think we got two quick examples to go. Well, if that's 83, what's the value of X? Yeah, it is whatever it is to add up to 180. Where's a calculator somewhere? And I'm in the way again, right? So if 83 adds up to 180, 105, what is the value of Y? Again, adds up to 180, so it's 75. Make sure you don't write, it's not 105. They're not equal to each other, they add up to 180. Maybe I'll just leave that as a crossed out. And then if that's 110, what's the value of X? Well, it's also 110, but please make sure you're writing out X equals 110 degrees, reason exterior angle of cyclic quad. Please, always when you're doing this, okay, you figured out the diagram, but keep practicing writing it down. So easy to go, I did this, and then suddenly when the diagrams get more complicated, or even when they're simple enough, you just write 110 and you haven't put a reason. 2 marks here, 1, 2. What a waste to lose that mark. It's not about the marks, but just it's important to show your reasoning. So it's good to practice doing this. Okay, exercise 10, give a few a go, and we'll be back with tangents.